Hi. This talk doesn't fit in this track. Okay? I'll be perfectly honest. When I wrote this talk, I looked at the track to put it in, and there was a lot of options. As you guys have seen, there's tons of content this week, right? So I was thinking maybe this is a good architecture talk. But for the architecture track, we tend to dive deeply into solutions. So you're thinking about doing a media streaming app, and you dive into the nitty-gritty, the details of that architecture. This doesn't really fit there. So then I thought maybe the security track. You see, I work for a security company. There's security in the title. This would be a good fit there. But the problem with the security track is it tends to be full of security people. And don't get me wrong, I like security people. For those of you in the room who are security people, you're my people. But security people have a very definitive mindset. I don't know if you've ever dealt with security people. We tend to like one two-letter word very, very much. So this wasn't a good fit there. So then I thought maybe DevOps. DevOps track is great, but the problem with the DevOps track is that it tends to focus a lot on tooling and a lot on teaching developers how to do some operational stuff, right? And then, of course, marketing, and no offense to the marketers in the audience, marketing has gotten hold of the term DevOps, and now, we're 2 steps away from DevOps toilet paper, right? Anything you can think of is being branded DevOps, DevOps, DevOps. So we ended up here in the compute track. And I think this is a very different talk for reInvent. I've been fortunate enough to be at all the reInvents so far. And there's a kind of a standard format for a reInvent talk. Normally, you're talking about a cool solution or a new technology or a service or a use case for AWS. You walk through your design, some of the ups, some of the downs, and then hopefully you get people excited about that technology and they walk away and they get to use it at home. This is different, and I'll get into that in a second as to why we're different here, because we're going to be talking a lot of areas that you might not be comfortable with, that you might not be used to talking about, but I think they're really important to address. But before we get started, I want to cover a couple logistical things, because this reInvent is very, very different, and we're in a very big room. But a few things. You might have noticed in the abstract for this talk that it is a sponsored session. It's sponsored by Trend Micro, my company. We're one of the diamond sponsors. Put your mind at ease right now. This is not a sales pitch. Beyond the next 5 or 6 seconds, I will not mention Trend Micro again. We have a big booth down in the expo hall. Come see us tonight at the reception. We're next to the beer stand. Very important. The food stand is on the other side of our booth. Very strategic. But we got a great team there. You'll see them there in red all the time. They'll talk about what we do. Here, we're not talking about that at all. Second thing as well, I know a lot of people's schedules are jammed, right? There's a lot of overlap, and if you're in a session in another building, then you might have to jet early from this one. I'm going to assume anyone who leaves early is purely for scheduling reasons and not a judgment on me. So I'll feel good about that, and you can not feel bad about ditching me halfway through this talk if you have to. So don't worry about that. So what we're going to talk about today is what might be a new idea, okay? Because I think a lot of us are working day to day in our companies with a lot of constraints and a lot of challenges that we don't necessarily have to have. We're doing a lot of things more complicated than we need to be doing, simply because of the way we've set things up, the way our teams are structured, and the way we're deploying some technologies. So some of this, it might be a new idea for you. Don't feel bad if it's a new idea. Maybe it's an old idea, and you're like, yes, finally someone is talking about this out publicly. So I hope we get some good discussion around it. Downside, I'm sorry about this. We have to talk about process, which is nobody's favorite topic, unless, are there any auditors in the audience? Or lawyers? Okay, so, one, sorry. Ex-lawyer, okay, then you're forgiven. So nobody's going to enjoy the process section, but we have to get through it, because it'll set up the idea. And it's really important because also as technical people, if you're talking to non-technical people, this is their language, not ours. And it's important to talk to people in the language they understand. But we'll get through it real fast, don't worry. And then we're going to talk about the breakdown of operations required in each of the main compute types in AWS. So as it stands at the moment, because we're pre-keynote, and you all know to expect an avalanche of new stuff in the keynotes, so for the next 18 hours, we're cutting edge, and this talk is correct. It's a win. And I'll tell you a funny story about that in a second. But we have really 3 main areas of compute in AWS. We've got EC2 and Elastic Beanstalk, and no discount to Elastic Beanstalk, but we're just going to group it with EC2. We've got ECS, so the EC2 container service, right? For those of you, Docker, which is now becoming our next DevOpsy buzzword. That's containers, ECS. And Lambda, so also probably going to eclipse as buzzword of the week. Lambda and serverless. So those are our main compute types. EC2, ECS, and Lambda. We're going to look at the responsibilities you have as a user and the technologies and the monitoring and the operational requirements for each of these compute types. Then we're going to figure out how to blend it together, how to make sure that it's all unified into one stream. Okay? That's the goal here. We want to reduce our workload. We want to do less work. Then we're going to put it all together. We're going to look at some code that's available. It's up on GitHub, or it will be after this session, and that you can play around with to put this into practice. So it's not all soft skills talk here. We are going to get into some code you can play around with as a proof of concept. But before we dive into that, I want to tell you a bit of a funny story, because I did mention that we're pre-keynote, and I want to thank the AWS team for that, because it makes my job a lot easier. You might have noticed, how many people have been to reInvent before? Right? A good number. OK. So you guys especially have noticed that this year's kind of crazy. Right? It is ridiculous. So 5 years ago, this conference was less than 2,000 people. And this year, depending on what day and who you're talking to, this conference is either 18,000, 19,000, 20, 24, or 30-some thousand people. Right? It's insane. Because of that, they've done an amazing job getting all this stuff together and making the logistics work. But as a part of that, as speakers, we had to have our talk titles and our abstracts in a couple months ago. And I thought I'd be clever and name this talk, Serverless to 32 XLarge. I submitted it in. They were like, yeah, OK, this sounds interesting. Sure, we'll let you do it. And when they got back with the response, I went, oh, crap. While it sounds cool to go, we're doing the whole breadth of AWS compute from serverless to 32 XL, I guarantee that we're getting some cool new toy in an instance type, either tomorrow or in Werner's keynote on Thursday, where this will no longer be the entire spectrum of AWS compute. It has happened to me every single year on stage at reInvent, where I've been talking about something that AWS has either rolled out a feature that solved that problem, or have eliminated the problem entirely, and I'm up on stage saying, hey, yeah, here's 20 minutes of a deep dive of how to fix this problem that as of 8 a.m. this morning is a checkbox, and you can just ignore everything I'm about to tell you. So thank you for the AWS events team for getting me in ahead of time, because I'll take that as a win, that for the next 18 hours, serverless to 32 XL is the entire spectrum of compute. And I'm looking forward to whatever monster instance size gets announced this week, because we all know there's one coming. 64 XL, 128, data center and instance types, who knows? It'll be awesome. So with that, I want to put an idea out there to you. And before I do that, I want to know how many other people I'm going to offend. So full-time security roles, hands up. Couple. This is also another reason I'm hiding in the compute track and not in the security track. And you'll probably figure it out by now, I like interactivity. So I'm going to pick on you, especially the people way, way back in the far end. Simply because you're hiding in the back and I can barely see you doesn't mean I'm not going to pick on you. So apologies to the security folks. I'm a Canadian. I apologize for everything. But I will stand by this statement that I'm about to make. You should not have a security team. Yep. Again, sorry. But that's a Canadian sorry, so take it for what it's worth. The reason being why you should not have a security team is because security is everybody's responsibility. Yeah, not as many woos on that one, eh? You're like, oh, damn it. So if you disagree, I will tolerate light to moderate heckling, OK? But I think this is true. Security is everybody's responsibility. So if you think the very basic example, think of your office manager, right? They're responsible to not give out information, like personal information, to random people who show up. But as developers, and I assume most of you are developers or builders, you're here at reInvent, right? You're making cool stuff in the AWS cloud. Security is your responsibility. If you aren't comfortable with that, it's not your fault, OK? One of the major reasons why people don't think this is true is the way we set up our organizations. I told you this was a weird talk for reInvent, right? How many people have seen an org chart this week, right? Yeah, exactly. But on the bright side, now you got something on Twitter. Hey, this weird dude's showing an org chart on stage. What the hell? So this is a common organizational chart for most big companies, right? You got your CIO on the right hand. Under the CIO, you tend to have the three big pillars. You've got development, right? So they're ideally working with business or customers to build cool stuff. You've got the infrastructure teams who are slowly disappearing, as we all expect with AWS, because AWS is giving us more and more of our infrastructure, which is a great thing. But these are the people who are running your core switching, right? Your data center, they're running the power, the cooling, they're helping with facilities. They're key pieces of a traditional enterprise. And then you've got operations, which is sort of the grab bag of everybody who didn't fit in the other pillars. So you get the support, frontline support people. You get the people who run like your Exchange server, your Active Directory, stuff like that. They all fall under operations. Makes sense, right? Everybody in a big org, that's kind of like your structure is. Yeah? This is when we nod or wave or grunt or throw something. There we go. Thank you very much. OK. So you'll notice on the other side, we've got the CISO. And the CISO is a little lower than the CIO because nobody ever really knows where to put the CISO. That's a whole nother discussion, and I apologize to any CISOs in the room. I'm apologizing a lot, and I'm sorry for that. But the CISO also has, so they have this pillar called GRC. Now, GRC is a security term because we like to acronym everything. It stands for governance, risk, and compliance. And this is a lot of the stuff that you think is actual security work, right? So it's setting out policy, it's doing audits, it's doing some forensic investigation. It's doing everybody's favorite compliance activities. Yes, right? HIPAA compliance, PCI compliance. Yeah? No? That's an appropriate reaction, by the way. Nobody enjoys compliance, but it is an important part. It's the assurance that everything you're doing is doing what you expect it to be doing. And as convoluted as that sounds, that's actually what that entire pillar does. But you'll notice that there's a little bit of redundancy. They have operations and security as well. And for anybody who, well, there's nobody in HR here. That's a safe bet. I won't even ask. Anytime you see two groups with the same title on an org chart, you should start to worry. And that's what we're going to talk about. Because the operations under security tends to be people who run the firewall, people who run the breach detection boxes, all these security appliances and different activities that are dedicated as security, right? But there's still a whole other operations pillar. I don't think that's right. And I'm going to tell you why. Security is a result of building better. So if you do better at building, if you build things that are highly available, redundant, durable, right, all the wonderful things that we're moving into the AWS cloud for, as a natural result, they tend to be more secure. So a lot of the time, you'll ask a question or be asked, is this secure? That is the worst question you can ever ask a security person, because you're missing a key component. Against what or who? Security is not a binary decision. So if I say, hey, this app is secure, I don't know what I'm talking about. Okay? Because if I'm trying to protect it from some script kiddies who are just running random tools they found on GitHub and are going, oh, I'm attacking everybody, then I should be able to stop that. But if I have a dedicated set of nation-state actors or cybercriminal gang that have decided to take me down, that's a completely different threat model, right? So security is a spectrum, but the end result is if you're building better, by default, you're going to be more secure. I told you it's weird. So one of the things that we've all seen moving into the AWS cloud is a rapid change in how we're delivering IT in general. So if you notice, and for those of us who are a little bit older in the room, and I will say that simply because I shave out all the white and gray so that you can't tell, when we dealt with physical servers, we used to deal on the term of weeks, right? So you actually had to call up your supplier, see if it was in stock, and if it had the configuration you wanted, then write the PO, they'd ship it in, you'd unbox it, you'd rack it, you'd stack it, you'd set it up, and all good. And you're like, yeah, we did that in 5 weeks. That was super fast. It was good, though, right? Then we moved to virtualization, and we started to work on the terms of days. So I remember the first time when I was working with a team, an operations team, and we made a request on a Monday, and we got our Windows server on Friday. We were blown away. Like, wow, like 5 days, server. Amazing. Of course, you're probably looking at me, well, you are looking at me like I'm crazy. It's, again, very valid, because we all know when we move into AWS, now we're dealing on terms of minutes, right? I make one API request, and I have 1,000 instances in EC2, and they're all green across the board within a minute or two. That's awesome. It's amazing. But as we start to move into containers, things now shift to the time frame of seconds, right? We're up and running, and our services are available in seconds. When we push all the way to AWS Lambda, we're talking essentially immediate, right? The service bills by the millisecond. So the startup time is there, right? Now, for most organizations, you're operating on a spectrum. As much as we all love the good story where somebody comes out and says, I'm 100% all in and everything's Docker, realistically, they've still got EC2 instances. For organizations that are a little bit larger or a little bit slower, you tend to be on the left side of the curve. So you still have sort of the rack of shame in your data center that you can't get rid of yet, but you're slowly moving. You got more virtualized. You're moving more and more into EC2. And some crazy team somewhere that you don't really know what they do is probably experimenting with Lambda, right? But you don't have any real meat there. For smaller organizations or more forward-thinking organizations, you're over on the left side of the curve or the right side of the curve. So you've got most of your stuff, if not everything, sitting in EC2. And then you're pushing stuff into containers where it's appropriate, hopefully. Hopefully we all agree where it's appropriate should be appended to everything that we choose to deploy. And then you're starting to get more and more workloads in Lambda. And if you haven't started doing Lambda yet, check out the schedule this week. There's a ton of stuff. There's a serverless mini-conf over at the Mirage, I think, with a lot of great customers who have real workloads, massive workloads that are running in serverless right now. But when you sum this up together, we kind of get this deal of why we're moving into the cloud is because we can move faster, but more importantly, we can focus on delivering value right into our business, okay? That's really weird even to say to you as a technical guy. But I read a fantastic article, and I'll send you guys the link shortly, about the fact that serverless compute and microservice design let us actually make intelligent decisions about where we want to put our resources from development perspective, because we know the cost of specific functions within our application. So if querying the database to get the nightly report for customer spend is taking 20% of our actual outlay of cash, we can put resources on that to reduce that and get immediate value. That's the first time in 40 years that we've been doing corporate IT that we've been able to be that efficient and that accurate, which is kind of scary given that we've been doing this for 40 years. But it's nice, and it's good, and it's something that you can start to make real traction with. But it sort of leads me to this principle that we're looking at. Our goal now is to be able to deploy to the location using the method, the location that we want, and using the method that's going to deliver us the most value. I can't even say that right. It feels weird. Does that sound weird to those of you who are working in development? Nodding is good. Shocked confusion, also acceptable, right? It's a weird thing to think about as a developer, as an engineer, to think about value. But there's some constraints that we need to worry about here as well. Every tool that we add to our chain is going to add overhead. So it's not just cost overhead, but it's something that we need to run. It's something that we need to learn, right? So we need to figure out if we're going to add Jenkins into our tool stack, somebody needs to know how to run it. Somebody needs to know how to maintain it, how to operate it, how to keep it going. If it breaks, we need to know who to yell about, right? So every tool adds overhead. But we can compensate for this overhead by doing more automation, because automation gives us the speed, the scale, the consistency that we need. Okay? A security assumption that is made during this whole process is that our data and our infrastructure, the security of that is integrated and automatic. People don't tend to go out and buy security. You buy security because you have to or because you feel that you've got a vulnerability or a weakness in your normal flow. But the assumption is normally that it's there. So since I've confused all of you at this point, because you don't normally think about the soft stuff, and I mean that in a very polite way, again, Canadian, very polite, very apologetic, I will make an assumption that you will all agree with me on this, that doing 3 times the amount of work is a bad thing. Yeah? Does anyone argue on that one? We can have a little discussion and see if you want to do 3 times the work, right? I don't like doing 3 times the work. So you'll notice I use 3 for very specific reasons, because we've got 3 types of compute, and that's what we're going to dive into. Because if we look at our goal of deploying to the location and using the method that delivers the most value, we need a caveat there that goes with no additional overhead or minimal additional operational impact, right? And right now, a lot of companies, a lot of teams that I talk to tend to treat EC2 completely different than ECS, which is completely different than Lambda. And you shouldn't. I'm going to show you how. So I'll go back to my original thing that I was glad that you guys cheered about. You should not have a security team. Thank you. Very much appreciated. I know who's getting beer after this. You need a trust and assurance team. These are the people who do that GRC stuff, because that is independent. That does need to be done. You do need to be compliant to different things. But you need an ops team. And I didn't call it a DevOps team, because I don't like that term, because I think it's isolated. Basically, what you need is a team that gets stuff done. Because this is how we run things in AWS, right? You are, also horrible term, the full stack engineer. You need to understand how all of this works, because all of it's code. As a developer, you've got a leg up, because you get an API spec and you know what you're getting back, right? But you still need to understand what's going on. So this is your goal, not a security team, GRC team, trust and assurance guys, ops is a unified activity. Security ops, standard off-the-shelf ops, development ops, all of it is just ops. I say getting stuff done because I don't want to swear. Okay, you're with me so far, right? No mass exodus yet. Of course, as I say that, everyone's going to get up and bolt. So we're going to talk a little bit more about some process. I'd like to know, from a show of hands, how many people have seen the shared responsibility model before? Thank you. Okay, a good amount. That's great. This is pitched as a security model. It's really the operational model for AWS. So you see on the left-hand side, we have infrastructure services. And the underlying concept here for all of these services is that there are 6 main areas that you have day-to-day operational responsibilities in. Right? People have to do things to keep this stuff running, whether it's the physical, infrastructure, virtualization, OS, app, and data. As an AWS user, that responsibility, the responsibility for these areas, is shared between you and AWS. The key is understanding where that division of responsibilities is, because it changes for every single service. So if we take EC2 as an example, we're all the way on the left as an infrastructure service. We take over at the OS. Right? You ask for an instance, and you get either access to Windows, or you can SSH into Linux, right? So you can do whatever you want. You're responsible for all of it, and you have the freedom to do whatever you need to do. You also have the freedom to shoot yourself in the foot. But on the bright side, we know how to manage operating systems, right? We've been doing this for a long time. We know that we should not give everybody admin privileges, right? OK, I'm worried at that reaction. I'll repeat that just for politeness. We know we don't give everyone admin privileges, right? Thank you. OK. I was going to say, the next question I was going to ask was, what's everyone's domain or IP address for your production servers? Because we'd like to run some tests for you. OK, so we don't give people admin privileges, but you could, right? You know, you're also responsible for patch management, for locking the OS down, for hardening, for all this kind of stuff, for installing your entire stack. Because the advantage of EC2 is that you get all that flexibility. The disadvantage is that you get all that flexibility. You need to know what to do with it, right? And I'm really trying hard not to give you a Spider-Man quote right now, but you know what I'm talking about. But when you move all the way to the other side, and you look at something that falls under what AWS is now terming abstract services, or software as a service, so think something like S3. Right? In S3, all we need to do is put an object or a key into a bucket, configure the policy for accessing it, and we don't have to worry about anything else. Right? We have some knobs and levers that we can adjust, but we don't run the S3 application. We don't have access to the OS underneath it. You know there's somewhere in the cloud of AWS, there is an OS that runs the service for S3. We don't care about it. It's a beautiful thing. It's some AWS engineer's job. So that's the shared responsibility model. You need to figure out where your responsibilities are and make sure you're fulfilling them. But if you flip that model a little bit, you'll realize that there's 4 main areas that you need to be concerned about. Essentially, initial and ongoing effort, your level of flexibility, and the level of risk you're assuming. So with EC2, again, on the left-hand side, there's a lot of initial effort to set that up. You can make that easier by automating it, so using a tool like Chef or Puppet or Ansible or OpsWorks. But you get a lot of flexibility. But you also have a lot of ongoing effort. So you need to make sure you're doing patch management and updating it and making sure that it's, there's a lot more monitoring here. You also get more risk, because like we talked about, you don't give everyone admin privileges. You also don't open up security groups to the world, ever on an EC2 instance, unless you're running a honeypot. Other than that, they should only talk to ELBs or ALBs or other instances. OK. Just checking. That was good. OK. So as we move over and we get closer to things like S3, you'll see that the initial effort, ongoing effort, things like that decrease. But there's still a big difference between different types of compute and different types of services, right? There's way more effort for areas that fall under infrastructure. So we want to make sure, or we want to try to reduce those effort. So the flexibility is always going to be the same because it's part of the service. But we want to try to normalize the amount of effort, and we want to de-risk using each of these things. And we're going to do that by automating a lot of this. And this talk, the rest of this talk is going to focus on the operational aspects of that. OK? So we're going to start again with remedial process, simply to make sure we're all on the same page. And I appreciate the amount of attention I'm getting. I didn't think this was going to go over this well, because it is a lot of soft stuff. This is a very technical conference. but I promise you it's important. So how we fix a problem depends on who you are and how you tackle this. But basically, problems fall into three kind of categories when you're dealing with them in production. It's a development problem. It's always a development problem. It's an operational problem. It's OK, Jeff. It's an operational problem, or it's a security problem. Now, a lot of people think that there's a massive difference between these three types of problems. There's not, and I'll show you why. So here is really high-level abstraction of how a development problem gets tackled. Basically, you have different types of input. So in this case, you've created your own patch, or you have a patch for a framework you're using. You have a bug report, or the bad one when a customer tells you something broke. Ideally, you never get to that point, and you've got enough monitoring in place that you don't have to have your customers tell you what's wrong, but it happens. So something is an indicator that there's an issue, that you need to tackle, that there's a problem you need to fix. You're going to do some sort of evaluation, some sort of estimation on the problem, trying to get a scope for it, trying to get some boundaries around it. Then you're going to do something to resolve it. Very simple, right? I like to keep things simple, clean, easy. No disagreements? Awesome. Good. I will also take silence as complete agreement with everything I say. So if we look at operations, it's, again, very, very similar. You see, it's the exact same structure. The difference here is that we have different inputs. In this case, we also have patching, but a lot of the time this is a patch. So if you're running like Active Directory, this is a patch that Microsoft issues out, right? We all hate Tuesday mornings. There's a reason. But you have to deal with it, right? Or in the case of AWS, there's a provider update. So great example for those of us that use EC2's management console a lot. We've been getting notified for the last 9 months that longer instance IDs are coming, right? Hopefully no big deal, but it's nice that we're getting that heads up. But there's a situation where our provider is saying there's a change coming. You need to deal with this and figure out if it's going to be in scope for a problem for you. And then we also have sensors. So in this case, we've deployed some sort of monitoring tool or service that is going to give us information that there's a problem. Then we're going to do the exact same thing developers do. We're going to evaluate the problem. We're going to try to get a scope around it, get some details. Then we're going to take some sort of action to resolve it. Right? Not rocket science. For security, it gets a little bit different, but not much. Security, we have a lot more customers telling us that there are problems, because security tends to be a little more nuanced in the problem. So fantastically terrifying example. I checked into the airport the other day, automated kiosk. Got halfway through to the bag, checking my bag. When it printed out the bag tag, it was somebody else's name. Yeah, security guy, I went, what? OK, that's not good. Can I change his seat? Yeah, I can change the guy's seat. OK, there's a problem. Please come help. Customer report, right? Also for security, sensors. Sensors, same kind of sensors you see from operational, plus some additional ones. So I already mentioned honeypots. That's when you set up fake-looking services to try to get people to come attack them, and you can get extra information. But you have these sensors that give you this information. We do the evaluation. By now, you guys are smart. You've all figured we have a new step. Yay. In containment. So containment is a sort of a unique security step in that when there's something happens, especially if it's an active attack, we try to make sure that we box it in so that it doesn't get worse. Very simple, very logical, right? So if you have somebody's doing a DDoS against your site, you're going to try to contain it so that it doesn't take everything down, right? You're going to try to isolate it. You're going to block a bunch of IPs in the edge. If you have a malware infection, you're going to try to disconnect the infected ones from the system.
So question.
Yeah.
Where's the FBI up there that tells you can't contain it because they want to watch it?
Sure. So good question. The question was, where's the FBI that says they want to watch it in progress? Actually does happen, not necessarily just the FBI. But sometimes what we need to do is we still need to contain it, but in a way that we're monitoring it closely. So you're upping it, and so there'll be an activity if you're getting attacked, if it's especially interesting attack, if you're drawing the FBI, it's very interesting. Then what they'll want you to do is essentially gather more evidence. So we've all seen any number of the CSI or Law and Order shows. Right? When they set up a sting, it's essentially the virtual version of a sting, where you're letting something continue to gather more evidence. Done a few of those myself. Super fun, super cool. Not as cool looking as in the TV shows. Very boring because you're still sitting in cubes monitoring things. But at a high level, we'll just class that under containment. So then you go to resolve this again. I'm sure you've all figured out by now where we're going with this. This is one flow. This is purely one flow for operations. This is why you don't need a dedicated security operations team. Every single one of these activities has some form of input, some way to evaluate, occasionally contain if it's a security one, and then a resolution. So we're going to build something, or I'm going to show you something that you can build very easily that will implement this in your AWS deployment. Now is when we get to the super fun stuff. But I appreciate the patience because I think you need the setup, because you need to understand that when you deploy something like this, and if you go to a team and say, you guys shouldn't exist, you're going to get some pushback. Right? I don't know if you ever tried that. If anyone wants to try that, please record it and then share with a group or live stream it. That would be really fun to watch. So you need to understand the reasoning behind this. And the reasoning is efficiency. It's moving faster. It's focusing on value. So what I'm going to walk you through is how to set up this very, very simple architecture. We're going to take a bunch of inputs. So you can see in the bottom, and I think I have the weakest laser pointer ever. I should have taken the green one. I was offered a green one. I opted for red. Bottom left hand, challenge with isometric diagrams. Left-hand side, we get a bunch of variable inputs from different AWS services. We're going to jam them all into one big Lambda function. And then we're going to take different actions with either third-party tools or APIs or no action whatsoever, depending on the situation. There's probably two things that pop to mind when you see this architecture. The first one is, hey, that's way too simple to accomplish what you've laid out. It's simple on purpose, because simple is easy. And it's very, very flexible because it's simple. The second one that people kind of pop out is they go, hey, isn't Lambda a massive bottleneck here? I would say to you, no, that's the beauty of Lambda. We don't have to worry about the scaling and the capacity planning. That's some AWS engineer's job, not my problem. I give it my function and just watch it go. There are limits on the number of concurrent invocations you can have on Lambda, but just like EC2, they can be removed very easily by opening up a support ticket and saying, hey, I'm estimating going 500 invocations per second. Please let me have that capacity. Here's the reason why. And boom, you're done. They track that just so you don't shoot yourself in the foot by accidentally setting up a Lambda that executes all the time. Also, it's a great way for the Lambda team to learn about how you're using the product and to get feedback, and a great way for you to make that connection to get some feature requests in. So we're going to talk about this. And in order to properly talk about this, we're going to dive into each area of compute. So we'll talk about EC2 and Elastic Beanstalk. Again, whatever on the Beanstalk, focus on the EC2. I know, I like Beanstalk, don't get me wrong, but there's no fundamental difference from an operational perspective. It's mainly a deployment difference, right? Because you still end up with EC2 instances, a VPC, and an ELB, and all these wonderful things. So we've got our architecture. What we're going to talk about is the bottom left-hand quadrant, the different event sources when it comes to EC2. First up is the safety net, AWS CloudTrail. Does everybody have CloudTrail enabled on their AWS account? Yes? Excellent. Great. Very easy to do if you don't, because they finally fixed, and this was one I had in a boot camp because I explained, hey, here's a great script to enable CloudTrail in every region. Finally, about a year and a half ago, they made it one check to deploy to every region or turn on in every region. And what CloudTrail does is it logs almost every API call made in your account. So if somebody calls run instances in EC2, you get a log of it. From a security perspective, that log also has an identity associated with it. So you know what access key, secret key, or what role called it, or what STS credential called it. It's a wonderful way to audit usage within your account. It's also what I call the safety net, simply because you can't count on it for day-to-day operations, because it is guaranteed log delivery, but the problem is timing. Currently, their goal target is 2 to 4 minutes after an API call, but we want to react faster than that. So it's a good safety net. And then we look at Amazon CloudWatch. This is one of my favorite services because people have very rarely do I meet somebody who understands the full breadth of CloudWatch. Because it was one of the first services, people kind of assume, oh, that's the service that I can set a metric and then alarm on. Right? So I can tell when my EC2 instances are consuming too much CPU, and I can raise an alert. Still very, very much true. That is the alarms feature. In the dashboard, you'll see that's under alarms. Super handy. We're going to use that a lot here. But they've also expanded to add two really important and critical things for operations in Amazon CloudWatch. Now they have Amazon CloudWatch events, which is currently available in a lot of regions, but not all. I'm hoping, fingers crossed, that we see that this week, that that's fixed. CloudWatch events is essentially CloudTrail in near time. So it will fire off a notification which we can hook our Lambda up to anytime a specific API call has been made. Okay? So if somebody makes a call to change a role in IAM or change a policy, you can fire off a notification and react to it. If somebody spins up or tries to delete an RDS instance, you can react to it. Right? So it's very, very handy because of the speed at which you get the notifications from CloudWatch events. The third aspect of CloudWatch that's extremely powerful is logs. By default, it will consume the OS level logs on Linux and on Windows and push them up to S3. You can also set metrics and alarms on the logs. Right? So these are great event sources. Bonus for CloudWatch logs is you can also add it custom for your application logs to be pushed up into the data chain. Now, one of the things that's really important to understand, even if you don't use the CloudWatch logs utility for setting metrics and alarms, because CloudWatch dumps them into S3, they are now applicable to be pushed into the big data chain and the data pipeline within AWS. So I'm not sure if, did everybody see the announcement 2 weeks ago that Amazon QuickSight is now generally available? Maybe-ish, probably not. Awesome service, check it out, quicksite.aws. Apparently they have their own TLD now. And it's a visualization tool. So you point it at a data source, like an S3 bucket full of your CloudWatch logs, and now all of a sudden you can start to do visual analysis without any coding on your part. So you can start to see when things happened, right? And you can start to break down and look at correlations between the two things. So these are our main event sources. And originally I had a video that showed you how to connect all this up, but I realized this is a smart crew, this is a 300 level talk. So you'll notice the bit.ly links here, they're all CMP305-001. It's all sequential. So you can just start at 001 and work your way through. All step-by-step from the AWS docs about setting up the things to monitor your instances. So in this case, first thing you're going to do is set up your alarms in CloudWatch to fire off to an SNS topic. Okay? I prefer to set up my alarms based on either auto-scaling group, because I don't really care about the individual instances, I care about the workload as a whole, or across all instances. And then after you've got those alarms, start to work down to specific instances that you really care about. But the idea here is that you're setting alarms that will then trigger an event, right? They'll trigger a notification. So a simple example is number of disk writes, right? So if you have disk writes spike, then there's a couple things that could be wrong. You could have an issue in your application because it was your developer's fault, and they wrote a problem, and it's just spinning out of control. It wasn't even looking. That was the best part. He's not even looking at it. And then, or it could be a security issue. We've all heard of ransomware, right? Ransomware tries to encrypt your files and then sell them back to you. Evil genius plan. Serious problem. But from an operations perspective, they both look the same. A massive amount of writes, reads and writes to your disk, right? You can set up those alarms through CloudWatch. Second thing you want to do is you want to enable CloudWatch events. I like to dump everything into the system and filter out later, but if you have a really active account, you might want to put some filters right into CloudWatch events. You can do everything you'd expect. You know, tell me only things that are launched by these identities. Tell me only EC2 run instances. Whatever calls you want to do, you can filter there. And then you want to set up your CloudTrail archives as well. Part of the CloudTrail process is that you can ask it to send out a notification on SNS every single time that a log file is created and put into S3. Okay, so that's now we've got CloudWatch log or CloudWatch alarms, we've got CloudWatch events, we've got CloudTrail, and they're all pushing into our SNS topic that's going to hit our Lambda function. The second two things we're going to want to do for EC2 instances is install and activate the CloudWatch logs agent. This is going to start to pick up the OS logs, and then we're going to want to add our custom application logs to that agent as well. So if we've deployed, let's say, a web server, now we've got the metrics around the CPU and network and things like that from CloudWatch. We've got the events around the API calls from CloudWatch events. We've got anything that's not caught in those two from CloudTrail. And then we've added CloudWatch logs to get the OS, so we're getting our Linux logs, we're getting our SSH installs. And then we've added a custom log to track whether it's Nginx or Apache HTTPD, whatever. We're getting all that through custom logs. So now we've got complete visibility pushed into either an SNS topic or some other mechanism to trigger our Lambda function. Okay? You guys get the concept? Right? Okay. So again, links are all sequential, so CMP-001, start your way from there. Very, very simple. A lot of them are scripts available from the AWS docs as well. So that gives us our EC2 instances, which moves us on to ECS. So ECS is essentially EC2 instance or a cluster of EC2 instances with a couple extra things running on top of it. So we get to very much the same thing here, right? We're still going to rely on CloudTrail. We're going to still rely on CloudWatch logs and events and alarms. The difference is that ECS is actually an application, and Docker is also running on that ECS. So we want to add some additional logging. And in that case, what we're going to do, we're going to set up the ECS instances just like we talked about for EC2, but we're also going to log the host Docker application and the ECS agent. Again, very simple step-by-step from AWS. But then we're going to set up a logging service for the containers that we're putting into ECS. So this last link here, 007, is a link to an article done by 2 of the AWS SAs that have a really clever solution of setting up a logging container service in a container sitting on ECS. So it's very simple. It's basically like an syslog server, and you just point your other containers to log to it, and then it pushes it all up into CloudWatch. Very, very easy to do, very, very low cost, and it kicks right into our funnel. Which brings us back to Lambda, which we're going to monitor Lambda with Lambda, very meta, very working. So again, we're going to talk about event sources. And the challenge we have with Lambda is it's super new, and no one really knows what to do with it as far as operations, right? It's really hard because all you've got is a function that you deploy. What do you do to monitor it? Right? Weird question, but legitimate. You're going to see a bunch of partners, I think, in the expo hall this week. There's quite a few startups who are trying to tackle this problem. From a security perspective, it's very interesting as well, because here you've given a function or a set of functions to AWS to run on demand as event-driven compute. And you don't have access to put firewalls in front of them. You don't have the ability to install a monitoring agent. All of this stuff is running for milliseconds. It's very ephemeral. So there are things that we can do. We can track in CloudWatch. We can track in CloudTrail, some basics around number of invocations, how long they're lasting, costing, things like that. But we do have the ability to do some stuff within the sandbox itself. So we can create some custom data points, and we can do some analysis of the Lambda environment. So we're going to set up our CloudWatch alarms for the general stuff. So this Lambda function is being called 1,000 times a second. OK, great. If that's our normal, that's good. But then we can monitor if there's spikes or drops to figure out what's going on. Then we're going to go old school. This is one of my favorites because it's so like 1980s Commodore 64 kind of print everything to standard out. When you do a print in Lambda, by default, it dumps it to CloudWatch logs. It's kind of handy. It is super old school and kind of annoying, but it works. Right? So if you're doing logging within your function, if it's a simple function, basic standard out print works. I would suggest being a little more robust and actually using, whether it's Node, Java, or Python, using the actual logging utility. You get a little more structure around it. Question?
If you dump out JSON, it'll be interpreted very nicely by CloudWatch logs.
Very good point. Thank you. Gentleman pointed out for us, if you dump JSON out to print, so standard out, CloudWatch logs by default will make that look pretty, which is really nice. It's collapsible, expandable, very, very handy if you're actually watching through the CloudWatch logs console. Very cool. Pointed out again, you can filter based on the keys. Very, very handy. Also very old school, but it works until we get something better. You can also do custom output from within the function. So here you're looking at some introspection. So for Python, which is my favorite, you're looking at like the OS or the sys modules, where you're saying like, hey, what OS am I on? What modules do I have access to? Things like that. Limited use, especially if you have a high invocation count of your function, right? Because it's not going to change. But it is a good way to figure out cold starts and if you're missing something. But again, there's a lot of active work in this area, and not just in the commercial space, but the community space, as people try to figure out what we need to do. Because we have this need to do something, but it's a really hands-off service, which is why I suggest you start there with your compute. Try to build it in Lambda. If that doesn't work, go to containers. If that doesn't work, go to ECS, because you noticed the setup gets successively smaller. So I want to walk you through really quickly here what this function does in the middle, the bottleneck. So essentially what this process is, we've gone through the different stages of compute, and we're shoving all of this data into this Lambda function. So what do we want to do in this function to actually process this, to make sure that we can do operational monitoring and make sure that we know that our environment is operating as we expect? Well, there's 2 real stages to it. What we want to do is normalize this data because we have this variety of data sources. So the way that CloudWatch logs spit something out is it's compressed. right? So you get a timestamp notification and then a bunch of compressed data that you need to decompress. You get from CloudWatch alarms, you get a different JSON structure. From CloudTrail, all you get is a notification that something was stored somewhere else. So you need to do some sort of normalization. And in this stage, you want to add some sort of identity tag to this event, a timestamp, and then ideally set it up as a series of key value pairs, right? So a hash table, basically, or a dictionary, whatever the language you want to deal with. Then you want to set up a response system. So you've normalized this data so that you can start operating on it. And then you want to do response. And in my case, what I set up I'll give you the URL so you can copy this. This will go live after this talk. Again, proof of concept. But what we've done in the response is basically set up a simple plugin system that lets you transform some of the data. So that CloudWatch logs example, decompress it so that you can start to actually look at the log data itself. And then maybe you want to do other transforms. So things like a CloudWatch alert. If you're going to push that to, say, a Slack channel, the CloudWatch alert structure is decently human-friendly, but you might want to change the JSON structure to something like, hey, you're beeped in US East, right? Because things just hit the fan. So whatever you want to do there, you want to do a transform. Then you want to do some sort of reaction. And this here is where the security aspect really starts to come in. If you see a large number of alert events or a huge amount of scaling, or you're seeing a large number of invalid requests, then maybe you want to take an action by tightening up a security group. So you can put that into the system and have it automated. So you're taking an automated reaction totally hands-off, right? And there's operational scenarios where you want to do that as well. And then you have some output. So very, very simple, but very flexible. So based on time, I'm going to skip the very straightforward video, which is just a whole bunch of text scrolling across. But essentially what you end up having is something like this, which is a default JSON from a CloudWatch alarm. This is what AWS spits out. So we're going to take that, and then we're going to add a bunch of new keys to it that we can react on. So I've called this project Cyclops because I like nerdy names. And basically what you'll see here is that we've got the original event in the raw key, but we've got the steps that we've taken. So we've classified this event, we've flagged it to send it to Slack, we've done a pretty print on it, and we've actually sent it out to Slack. So you'll see we've taken our alarm that has the details on the last slide, which was all the structure that you get from AWS, and we've translated it as something human readable, which is too many reads raised in US East, North Virginia. Right? So very, very simple. This processes in well under a second, and this is very flexible, right? So in this case, I said, you know what, this is good to dump this to Slack. I could also have it somewhere else. Again, another example, if we're looking at an AWS config rule. Config rules can output. They will push out a notification. And again, here we have this rule fired. Here are the parameters, the role, ARN, all this kind of data, which is great, but we can add to it. So in this case, what we've done is that we've added some transforms to it. And again, for this case, a good example, we're sending it out to Slack to let people know that there's a compliance issue. Okay? But because we have all the data moving through one place, we have one central point that is essentially infinitely scalable because it's Lambda, where we are able to take an operational task or an action based on whatever's coming in. And if you keep it very, very simple with this key pair structure, you can do whatever you need to do. So if you get that pushback from the security team saying, no, we need to exist, sorry, that was mean. If they say, no, we need a tool that does this, you say, that's no problem. What are your criteria for an action, and what's the reaction for that? So if then, if this, then this. And you set that up for every operational task, whether it's standard ops or it's a security-based. In a little more abstract form, we've got all the inputs pushing into our Lambda function. And let's say we just want to dump everything into an S3 bucket. So we're going to format everything as comma-separated value, and we're going to dump it all into an S3 bucket because we want to connect it to Amazon QuickSight. That's that new visualization service from AWS. So we want to see every metric or every event that we have in our deployment, we're going to dump in this bucket. It gives us a central point that we can now start to visualize on. Might not be super useful, but if you expand that out to the next step, now you're manually being able to look at this information in a visual way, as opposed to going through log lines or JSON documents, and say you start to see a pattern that you want to flag. Well, then you can start to push that into something like a Dynamo table to be a little more complicated, to give a couple different variables. And you can react to multiple indicators by doing something. So if we walk through a security scenario, and security, a lot of the time, we have to find multiple little hints that something else is going on. It's very rare that a security example is just like, boom, this is the problem, right? Same with trying to track down a bug in like a multi-threaded system, right? You're looking for little nuggets that kind of tweak that idea that you go, oh, that's the problem. I forgot to close this function off, or I forgot to call this. Same with security. But this way, we've set it up because we're pushing everything into the one Lambda function. As an offshoot, we're shoving it in S3. We're giving our teams an ability to visualize it through QuickSight. Then we're setting up multiple key indicators in Dynamo and making a change maybe in VPC routing because we saw that somebody is trying to short circuit some of our security controls to get where they shouldn't be. Just one potential scenario. Or maybe we've detected malicious traffic coming in from somewhere that it shouldn't be, so now we're going to add WAF rules instead. The point is this system ends up working very, very flexible for not just standard ops, but for security as well. We've never been able to do that before because we've never had access to all this data. It was always in different systems. It was always in different formats. Now, with a couple quick lines of code, we can make sure that it's all formatted in the same way. So the key takeaways that we've got here is that you don't need your security team. Sorry, guys. Everything, this is all just ops, right? This is all just getting stuff done. It's just the way you need to deliver services in the AWS cloud. So the key things to remember how you want to get stuff done. You want to make sure that you're not duplicating process, right? When you step back and look at that workflow, that first half hour of this talk that you were all so kind to sit through, when you sit and do that in your own organization and realize that a lot of people are doing the same thing with completely different tools or different perspectives. Get that together. Don't duplicate your process. Make sure you can gather all the data everywhere you can. It's super cheap to store this stuff in AWS and process it. So even if you're dumping it all into an S3 bucket, right, you can just set up an easy lifecycle policy and push it to Glacier and store it for insanely cheap prices. We don't have the same constraints we used to, so why not get all the data you can? We've got the tools to sort through it really, really efficiently now. You want to normalize that data. You want to add some identity so you can refer back to it. And then you need to figure out how you're going to react and resolve. That's the big key here. I appreciate it. We'll do a little quick Q&A. For those of you that need to leave early for sessions, please remember to complete your evaluations on the mobile app. There is extra swag that you can get by completing your evaluations, so there's some motivation. And as speakers, we always appreciate it. If there is some Q&A, we've got 3 more minutes before we get booted, and then I'll be here afterwards. So please come up to the mics if you have a question. If not, come up front, and we'll chat after. Thank you.